Okay, now we're on week 3, which is the last week of our review, and we're going to go forward um, reviewing the link layer, and then after we're done the link layer, we're going to do the physical layer. Now, physical layer, for those of you in 475, was not discussed in the class, so once we finish link layer, we are finished our review, but um, we still are going to cover physical layer this week as well. So let's get started. Let's first of all start off by defining some terminology that we're going to use in this lecture. So since both hosts and routers participate in the link layer, um, and they'll kind of work very similarly in that sense, we're going to refer to both hosts and routers with the term of nodes. I'm sure you're familiar with that term. Um, We're going to talk about the communication channels that connect adjacent nodes along communication paths. Um, we are going to refer to them as links, and we're going to talk about 3 different kinds of links, wired, wireless, and local area networks. We are going to refer to a layer 2 packet as a frame, and a frame basically encapsulates the datagram. So basically, to define what the link layer or data link layer does, it basically has the responsibility of transferring datagrams from one node to a physically adjacent node over a link. So basically, it's in charge of getting you, from point to point to point to point across all the different physical links until you finally get to your destination. And basically you have to deal with your local, traversing through your local links first, and then moving from one type of local link to another until you finally reach your destination. So basically, from end to end, the datagram is transferred by different link protocols over different links. So every time you have a different link type, you're going to use a different link protocol. This is very different from the upper layers where you're using the same protocol, from end to end. In this case, for the link layer, you can actually change protocols as you go over different links. So, for example, you can have a local Ethernet network, local area network that you start off on. So you start off with Ethernet protocol. Then maybe on your intermediate links, through a wide area network, you're doing frame relay, and then finally you're going to get to an 802.11 network on your last link. And each link provides different services. So a good analogy to kind of help you visualize what it means to change protocols throughout your trip. Let's say, for example, you're going to take a trip from Princeton to Lausanne. So basically, from your home in Princeton, you take a limo to the airport, you take a plane from New York City JFK Airport to Geneva, and then you take a train from Geneva to Lausanne. So if you think about it, kind of following along this analogy, the tourist traveling from Princeton to Lausanne is basically the datagram. So the datagram has to get from one point to another. And each transport segment is a communication link. So the limo and the plane and the train represent 3 different types of communication links. They all provide the same function, getting the tourist to his destination, but they're all very different in how they operate. And they're also very different in speed as well. So those transportation modes, limo, plane, and train, are analogous to the different link layer protocols. And so basically, just like you have to hand off the person from the limo to the plane to the train, you have to hand off a datagram to different link layer protocols. And then to kind of take this analogy a step further, if there was a travel agent that coordinated this trip ahead of time, that would be analogous to a routing algorithm.